Okay, coin problems I'm actually going to treat as mixture because if you think about it, we're really mixing or combining two different types of coins, or maybe even three, and that's going to add up to a certain amount of money. So I'm going to draw my table the same way, right? So I have my table with 3 rows. So the first one is going to be the number of coins, right? Coins. And if I multiply that by the value of the coin, I'm going to get the amount of money, right? So for instance, if I have 2 quarters, I would take 2 times 0.25 and get 0.50. And so the amount of money I have is 50 cents. If I have 5 quarters, I would take 5 times 0.25 and get 1.25, and I'd have $1.25. Okay, now the rows are going to be the types of coins I have. So in this question, we have nickels and quarters. So I'm going to write nickels and quarters, right? Quarters. And here's the mix, right? Here's the mix, right? So now I go about filling in my information. It says if Jane has 36 coins, right? So that's 36 here, right? And it totals $3. So those 36 coins total $3. So I put that there for the amount of money. How many of each coin does she have? So nickels could be N. Quarters could be Q. The value of a nickel is 0.05. The value of a quarter is 0.25. The value of a mix, each coin doesn't have a value because they're different values, right? And now across the top I have my equation, so I multiply the number of coins times the value. So this is 0.05N, right? N times 0.05. And the second one is 0.25Q. And just like mixture problems, the equations come down the first and the last columns. And if we look at this, right, the first column, I have a certain number of nickels, a certain number of quarters, and that equals 36. So N plus Q equals 36. The last column, right, I have a certain amount of money in nickels, a certain amount of money in quarters, and when I add them, I get $3. So I have 0.05 N plus 0.25 Q equals 3, or $3, right? Okay, and there is my system. So a couple ways we can solve this, right? I think it's probably easiest to get rid of the 0.05s down there in the bottom. So I'm going to multiply by 20, right? 20 nickels is $1, right? So I'm going to actually do it by negative 20 because I want to use elimination. So I'm going to multiply both sides of this equation by that. Now the top equation stays the same. N plus Q equals 36. The bottom equation, right, negative 20 times 0.05 is negative N, right? Negative 20 times 0.25. Now think about this. Negative 2 times 0.25 is negative 0.5. So negative 20 is negative 5Q, right? Or you could think of it, I have 20 quarters, right? So 20 quarters, 4 quarters is $1, so that would be $5, negative 5, right? And then negative 20 times 3 is negative 60, right? And now I can use elimination and add. So N and negative N cancels. Q and negative 5 is negative 4Q. And 36 and negative 60 is negative 24. And I divide both sides by negative 4. And I get Q equals 6. And now I substitute in. So I'm going to substitute into here, right? Right over here. And I'm going to get N plus 6 equals 36. N equals 30, right? So the answer to this question, I would write 6 quarters and 30 nickels, right? And if I think about this, does she have 36 coins? Yes, 30 and 6 is 36. Does it equal $3? Well, I don't know. 30 nickels, right, is $1.50. And 6 quarters is $1.50. So total, we have $3. So this would be my answer. Again, treat coin problems as mixture problems. Your equations come down the left and right columns, and you can treat it exactly like a mixture problem.